Hello, I'm Rachel Lee, and today in Naylight Labs, I am going to be demonstrating the reaction between sodium hydroxide and nickel chloride solution. To start the lab, we need two 50 milliliter beakers, 15 milliliter of 1 molarity sodium hydroxide solution, and 6 milliliter of nickel 2 chloride solution. So let's begin our observation. From the container shelf, I'll first put down two 50 milliliter of beakers. We'll label each beaker, beaker 1 and beaker 2. Now I'll find sodium hydroxide solution in the material shelf, which is right there, and pour 15 milliliter of it. Now I'll find, I also need to find nickel chloride, which is right here, and pour 6 milliliter of it into beaker 2. Now, as you see, sodium hydroxide is a clear aqueous solution right here, whereas nickel chloride is a green aqueous solution. So, what will be the product of these two solutions? Let's find out. I'll zoom in for you guys. And then, I will now pour nickel chloride solution into sodium hydroxide and see what happens. I'll pour it all. If you noticed, the final product is a green solid, which is nickel hydroxide inside the clear sodium chloride solution. I'll zoom in even closer for you to see. Now Stephanie's going to explain how this chemical reaction happened, why did the solid form, and tell you what the balanced chemical equation is.
Thank you, Rachel. So, how did we know that the product was nickel 2 hydroxide and sodium chloride? First, let us analyze our observations and reaction theory. There are four possible reactions we could have had. They are synthesis, which involves combining two reactants to create a single product; decomposition, which involves splitting a single reactant into its respective components; single displacement reaction, which involves a single more reactive element displacing another ion in a compound; or a double displacement reaction, which involves the exchange of ions from both reactants to create two new products. Knowing this information, let's analyze our observations. The initial solutions were both aqueous solutions of different colors. In our final product, we have just one green precipitate, which means we still have ions in solution. Thus, we have a total of two products. Now let's look at our chemical equation. As you can see, we have a total of four reactant ions, which are sodium, hydroxide, nickel, and chloride. The sodium ion in the sodium hydroxide solution exchanges places with the nickel in the nickel chloride solution, creating two new compounds: sodium chloride, which is aqueous, and nickel hydroxide, which is solid. This signifies that we have a double displacement reaction. Let's delve deeper into the properties of double displacement reactions. In a double displacement reaction, one ion from each of the two reactants is exchanged. These reactions usually occur in aqueous solutions. This is because in aqueous solutions, the original compound's cations and anions dissociate within water, allowing other ions to potentially combine with them. So in our reaction, sodium, hydroxide, nickel, and chloride intermingle in solution. The nickel and hydroxide ions react to create solid nickel 2 hydroxide. Since sodium chloride is soluble, its ions remain in solution. Results of double displacement reactions can be aqueous, solid, or gases. There are three types of double displacement reactions: neutralization reactions, which involve the neutralization of an acid and base; precipitation reactions, which involve the creation of a solid; and gas formation reactions, which involve the creation of a gas.